In that case, we are going to start. And Shimano, if you want a second microphone, be my guest, be my co-presenter. I would be more than honored. Welcome to my talk called Events Uneventfully, or Mistakes Were Made One Event at a Time, or however else you want to approach it. My name is Ax, which you know. The rest of the things are not really that important. We are still in a pandemic, and sadly, the Russian invasion of Ukraine is still ongoing. I hope it finishes quickly in the only way acceptable, which is Russians going back to Russia. And now, my name, if you need things from me, email me or tweet me, and I'll be happy to talk to you. If you want to talk to me face-to-face, do it one person at a time. I do not enjoy large crowds, which is awkward, me being here, but hey, here we are. Couple facts about me. I'm proud to have been to Java 1 when it was still a thing, and have been recognized there and so on and so on. Have been involved in communities, Java, for a long while, so you can say it's a hobby, and it's stuck. And definitely my opinions are my own, which means if I'm making a mistake, it's not intentional, but it might happen. I'm definitely not representing any employers, past or present or future, because you never know. And if you have any questions about the talk, just ask. I will barely see you. If you want to co-present, that will be unexpected, but hey, yeah, why not? There is also Slido. I have it open on my phone, and I know somebody here in front is also having Slido open, which means use it, and we'll try to make it as interactive as possible, which will be much nicer for me, because this is the very first time I'm giving this talk. And as you might know, if you've seen any of my previous presentations, I really like dry jokes and reminders to me that I need to drink. So, without further ado, especially for the guy in the first row, what is this talk? This talk has been motivated by one thing, or maybe multiple instances of the very same phenomenon called people. People trying to do events and people repeating the same patterns of behavior, which lead to unexpected or suboptimal results time and again, time and again. Life would be so much better if everybody knew everything immediately in the most correct way, but sadly or unfortunately, or fortunately because we get to meet because of that, this is not the case, which means people doing anything event related make some mistakes, and that's normal. And from conversations in corridors here today, I know that you've seen a fair share of those. And I've seen a fair share of problems. I've selected some. I don't know if I've selected enough or maybe too many. We'll see how this goes. They have been coming from many places. Some of them I have worked in, some of them I have not worked in. I'm not going to tell you where exactly which problem came from, because that would be too telling. So no naming companies, no shaming of any individual places. Yeah, collection of problems witnessed, which means if something is being discussed, it means sadly I have seen it. And I've talked to people who did it to other people. And yeah, obviously the goal is to not repeat it. Or if you see a colleague, a friend, or maybe an enemy that you want to be less of an enemy that's going down the rabbit path, that's going to end in grenades, send them a link with a timestamp, and yeah, hopefully they can be smarter, faster. If you've done a lot of event-related stuff, that probably means you know it all, and you might find it not as in-depth as you were hoping for. Be warned, this is not supposed to be a talk which is going to explain how to do events. So if you know how to build an event store, I'm not going to explain this. I'm not going to explain what event sourcing is in too much details. I'm not going to try to describe event-driven, event source, and everything else in too much detail, because that's not the point. There is a lot of really good talks, some from people in this room even, that already covered this area. And with that, enough of an introduction. Let's waste some internet, which tells you that there will be no cuts. Ha. So, event. What is an event? And what could possibly go wrong if we want to commit an event when doing software? Let's start with a definition. An event is a discrete fact. Discrete as in not continuous, rather than secret. And it usually is something in the past tense, which means something happened. Somebody joined a talk, somebody bought a ticket to GeeCON, somebody enjoyed a talk, or somebody, I don't know, made an order. Transaction has been processed, bank account has been debited, and so on and so on. You get the idea. Events usually are not in present tense, and they are not in future tense, because those are, well, processes in flight or hopes, dreams, expectations. On the other hand, events describe something that actually happened, and because they happened, they can be attached to a point in time because they are discrete facts. They are not large chunks of things. Or if there is a process and you associate with an event with it, you might have an event that says a process started and a process concluded. Or you might have an event saying a process started and never have the process concluded because process never finished. Both things can happen. And with that, that gives us a lot of power. And it's an extremely expressive thing, and it's also a very abused thing. But we learn as we go. One very important thing is not all events in software are equal. There are events which are important. There are events which are more important. And there are events which you can ignore and you don't care. Your software already does a lot of both, most likely. Or if not your software, then your operating system. There is events have been with us for a long time. If you read some of the older object-oriented books, like from the 90s, you'll see message passing, messages, events, almost the same thing. So that exists there. And you can have a couple of notions of events. For example, a notification. A bill has been created, issued. A debit payment has been scheduled for a user, and so on. Also, there might be an event which is a state carrier. For example, the data of the transaction will travel in an event because somebody decided to do that rather than use a post. Can be, and it's okay. If you want to explore that avenue, instead of talking more, I'm going to refer to everybody's famous software journalist, Mr. Fowler, who has a talk about it. I'm not going to play it because, well, that would be a thing, actually. And then collect all the claps as mine. Yeah? What could possibly go wrong? In your careers as software people working with sometimes web applications, you also encounter Google Analytics events. You'll encounter events coming from AWS things. Are they events that I speak of? Sometimes yes, sometimes not. It depends. It really depends what your application does, what the domain is. And I keep using the word domain, which means if you have never explored domain-driven design, this is another good avenue to explore. So let's have a look at something that can go wrong. Why display? No, that works. Mistake number 0, which obviously states my opinions on whether this should be started from 0 or 1. Issue number 0 is not making events when events should be happening. How can you recognize some of the symptoms? Definitely not all. This list is definitely not exhaustive. There are many more ways in which you can recognize it, but some of them I've seen recently where, for example, batch jobs, trying to traverse the changes within the last, for example, hour in the database, trying to seek for state changes, trying to then activate certain pieces of logic that would react to those changes. Could it be done differently? For example, when that mutation happens, something special like an event gets created, recorded, and then can be reacted to? Most certainly. Also, another symptom, now seen slightly less often, but still, huge audit tables. If somebody makes a change to a record in the database, and they just copy it over time and again, ending up with hundreds of copies, sometimes copying the whole record all the time when only a single value has been changed. It works. It definitely fulfills the auditing requirement. It provides a trail, sure. But maybe what that person means is somebody changed a field in the address, names the field. That was the old value, that was the new value, and then they react to it. Another avenue is building more and more on top of a CRUD. CRUD stands for create, read, update, delete, a classical REST endpoint or anything. And then one of the pieces of logic is going to, let's say, calculate balances, issue bills, send notifications via email, generate PDFs, schedule billings, because why not? And do something else, and do something else. And that method is actually taking 7 minutes. Maybe somebody put it into a batch job in a Lambda, and then it takes up to 15 minutes because then the Lambda gets killed. And that's a situation in which, yeah, there could be events. There could be events that would activate certain pieces of logic when they are due and when they should happen. Very long business methods. Some of them you can call by name, because if there is something like, I'm not going to read this whole thing, and, or if the body of the method is a couple hundred lines, or maybe a couple thousand lines, because we've seen those. Hopefully we've not made them all from scratch. But yeah, those are just some of the symptoms. You've probably seen others. External system interactions happening in an online way when they need to asynchronously happen, and that's what you are interested in, and they don't need to be initialized in the blocking path, making the main request path response longer. That's another symptom. So what do you do in that case? The answer is obviously easy. Try to introduce a concept of an event to the system. And if this strikes you as surprising, I've met a number of places within the past 12 months that don't do events. They should, but they don't know that they should. So it's a thing, and it will continue to be a thing because new developers are coming around, finishing universities. Knowledge doesn't fall from trees on people. It's birds what drop things on people, and that's not the same as knowledge, sadly. Introduce concept of events. Whether they are something that activate other activities or record, that doesn't matter. It has to be specific to your problem. And at first, you'll need to store those events somewhere. And that raises immediately a question, hey, I want to do events. Now, what do you do with events? Let's look at the books or internets or presentations. Oh, I need to use, I'm not going to name it yet. No, you don't need that. Most people will be perfectly okay with exactly the same database that they have for all their application state, for all their entities. Size will be okay, and activity will be okay. If you're in a very busy system, you probably are past this point already, so that's probably not, but the startups that do things, that's a very often thing that they need to start doing and isolating certain events and actually working with that. Another sign of this problem, there is an audit processor, so something that goes through all those copies of records and tries to imagine what actually happened in between the lines. Why not record exactly what you're looking for immediately and not have that problem? Because that's now twice the code for half of the gain. It makes no sense. One thing that my friend recommended me to include in this talk yesterday was, if your business has something called pivotal events, and there is a link if you'd like to read about what pivotal events is in more detail, then definitely record them in your system. What is a pivotal event? Something important for your business. Order added, checkout completed, user registered, or anything else. Depends on your business, obviously. But those crucial events, those important events, recording them is usually a good habit. There is usually not so many of them, but when you have them, you're going to be happy that you have them. And not having them is going to hurt because, okay, what can we do? Well, we can recover this information from logs. And then you discover that, yeah, some of the logs have been truncated. Or some of the logs never made it because your monitoring provider is actually guaranteeing 90% of log storage and not everything went there. Or maybe the log information says order created. Which one? No way. And let's expand on that. On the extreme end of this very axis is going all in on events. Everything in the system becomes an event. Every activity, event recorded. Every sub-activity, sub-result, every intermediate step, everything, everywhere you look, you see events. Obviously, some events are less important. Some of the events don't have to leave the system. Some of them don't have to be recorded. Going all in by default is going to cost. If you're a startup, experimenting, developing, I would actually caution against going this way because it's hard to retract because people will start depending on everything being recorded everywhere, and that leads to messy architecture. Okay, good. We've covered one whole mistake. Let's go further. We want to have events. That's what we agree on. And they have to be somehow identified. They can be identified by, for example, the ID of the entity that they refer to. If there is a transaction created, you can probably reuse the ID of transaction and maybe some type annotation, and maybe a state change. And that makes a good field. But often events will also have their own individual unique fields because you will want to browse those events if you store them, obviously. And you have some choices. One choice is a long, quite normal. Some people actually try to do ints, and then they get into funny problems, but we'll get there. Many people use UIDs. And recently I've met a couple of people who started mixing nano IDs with UIDs and expecting them to work like the same, but not really. And that led to funny problems, as you can imagine. So why not ints? Int has a range. Int usually has a range of 2 to the power of 32. That's not a lot if you expect a lot. Or also, if you publish your events into something externally reachable, and that's accepting IDs as an argument for searching, it makes it very, very easy to enumerate. And enumeration means somebody can go and fetch, check the endpoint by 1, by 2, by 3, by 4, and so on, and so on, and so on. Figure out all of the events, all of the state in there, and they can see how much traffic your service has. Is it the problem? Sometimes yes, sometimes no. So be careful. On the other hand, UIDs or anything that looks random or randomish doesn't have that problem because it's very hard to predict all of the UIDs. As in somebody tried, but they're still busy. So UID has also a structure, which means if you receive an identifier, if it conforms to it being a UID, good. If it doesn't, out it goes. And then comes nano ID. So what is nano ID before I complain about it too much? It offers some amount of random bits. It offers a wider alphabet than UID, because UID you probably usually see in a form of base 64, whereas nano ID can use most of the letters, small and large, and yeah, that then makes a shorter string. Looks great in a web URL, and that's probably where its utility ends. It doesn't have a dedicated storage type. And I know that there are some people who use a specific language that has a script at the end that quote that this is smaller and faster and better than UIDs everywhere. Before I react to it, I will ask, do you remember the left pad drama? If you do, then I don't have to comment. If you don't, check out the left pad drama before going further. This is useful, has a utility in the web space where you need to have a unique identifier that's shorter in terms of number of characters, but that's probably it. So UUIDs and types. So what does a UUID look like? We'll have a look in the... Actually, we can have a look at it immediately. For example, this is a UUID. You've seen a string like that before, for sure. It also has specific field type in databases, which makes it very, very awesome because you don't have to store it as 36 characters as a string or a varchar or however you store it in your databases. This will be stored binary, and databases can do smart things on it. And yeah, this is a UID. UID, this is the audience. Now you know each other. Some Windows people will call it GUID. I don't know why, but I am unable to use Windows properly, which means I'm not going to make any further comments. But UID has something that you might not be aware of. It has variants and versions. Why both? Why not one? Don't ask me. It's in the RFC. Version 1 is something that includes datetime and a MAC address in the UID. Version 2 is something that I'm not going to cover. Version 3 and 5 use strings as input to generate a hash, to then store it in the UID. And then version 4 is pure random. So if you pick a random generator of UIDs, it gives you options. It can have a random one. It can have one that's time-based. It can have one that uses a namespace and a name, so the string input for the hash-based one. And then it will generate a string that you want. One regard about timestamp, because timestamp identifier, that feels potentially useful, and we'll get back to that. But timestamps in UIDs are measured in 100 nanosecond increments since midnight, 15th October, 1582 UTC. Don't ask me why this date in particular. This is what's in the RFC. I don't remember it by heart, maybe. UID has versions, which means if you want to use the other one, you can generate one that's string-based, which means if you generate it again based on the same string, it will be the same. It's a useful property, or might be, if you want to, for example, encode, maybe not encode, but do a one-way transposition and then verify if that is likely to have been the same. Or it can be time-based. And the time-based is here. And because this is a very big screen, I hope you can see that. But if you can't see that, I cannot jump that high. This is the area that we're interested in. And somebody is probably thinking, hey, those characters look similar. Front is different, rear is similar. What's that? Well, time and MAC address specifically. So those are the network interfaces of the computer I was running this on. Here is what you have. Right matches the left, almost because they skipped the semicolons. But I mentioned timestamps, which means what can we do with a UUID in Java, because every problem becomes different if you add in Java. You would like to be able to generate an instance-based UUID. Sadly, not in the JDK. You have to write some code or ask ChatGPT to generate it. And you would like to extract time from a UUID. One caveat that you need to be aware of, precision of the timestamp stored in a UUID is not going to be the same as an instant now generated in modern versions of JDK. Which means if you expect 6 digits of precision, at the very end, you're not going to get that, you're getting 3, because 100 nanos increments. The code that would extract or store instant in a UUID looks like this. I don't expect you to memorize this. You can ask ChatGPT to do it, or you can find libraries that do it. There is a Jackson extension for this. It's a solved problem. The important thing for me is that you know about this capability. Because if you know that you can have a timestamp, a reliable timestamp, in your identifier, that means that you can, for example, optimize time-based partition search. Sounds awesome. You can optimize maybe sharding replicas if you want to do something else. And this is still quite random, quite well distributed. And because UUIDs are very unique, I'm not going to say that they will never have a collision, because we've been through such things. 640 kilobytes is going to be enough for everybody. And then year 2000 is so far away that's not going to hurt anybody. But UUIDs generally make a very good identifier for correlation IDs. If you have flows in your system that are initiated by a specific thing, by a specific event, by now, then using this identifier as the correlation ID is a reasonable choice. It's actually a good choice because you now have one less entity in the system present, because you don't have to have an artificial correlation ID and match it with the event. You just use the event that initiated a certain flow. And that brings us to mistake number 2. But before we go there, maybe your memories will come back. If somebody remembers this video, then you remember it well. And before we get into talking about delivery mechanisms, I'm going to make a recommendation of a talk about somebody working in a company that grows very, very quickly. Wojtek has a talk last day of the day, 1710. You probably want to see it because I've heard it's awesome. I've never seen it, but I've heard it's awesome. So relaying complete. Now, mistake number 2 when it comes to events. Delivery mechanism, or religiousness, or zealotry, or whatever you want to call it. Symptoms. How do you know that you're dealing with somebody who is a radical? Well, sometimes the clothes might tell that apart, but in terms of events and systems, if they say that, hey, we need to use Kafka, and it's only Kafka that we can use, otherwise we cannot do events, something is off. Or blockchain, or whatever your favorite piece of technology. I have nothing against Kafka in general, don't get me wrong, and I have nothing against blockchain if it's energy efficient and actually useful. But people have very strange arguments when it comes to event-related technologies. For example, ActiveMQ is terrible, period. Why? No idea. What's your context? I have no context. It's just terrible. That person might have some scars. Now, what is important for us, or what is important for people who actually need events transmitted, is they want probably a durable, so persistent, event delivery and distribution mechanism. Database, we already know, serves that purpose very well because that usually works. Can it be RabbitMQ? Sure. Can it be ZeroMQ? Sometimes yes. Can it be Redis? Yes, it can. Can I say that Redis never crashes and is actually perfectly reliable? Well, there will be caveats there. We can discuss it after. Definitely, if you've never done events, start with putting them in a database. That will be easier rather than bringing complexity onto you in order to enable things. And I'm not going to share any secrets when I say that there are successful companies which use Postgres as their event distribution layer. And it works. Old, boring, painfully reliable Postgres scales. I will not quote any numbers, and I will not compare them to any storage mechanisms that were described in this room today, but it can be done. And it works, or at least it works in those contexts. So that was discussed. How do you approach somebody having that kind of mindset? Of course, if they want to discuss and they still have an engineering mindset and they want to approach problems like an engineer, first of all, broker and storage can be separate. So if there is a problem of delivering events and there is a problem of long-term storing events, that's something that you don't have to use the same system for. And this is where, if you have nothing, database actually wins because it means one system less. You can always add Kafka to a system if you need it, or you can always add something else if you need it. For a no-clear idea, databases are useful because you probably already have a database in your system. And if you do, then just reuse the same pattern. Postgres is, as I said, scary good. That is also in line with my experience. If you need Kafka, my recommendation would be, if you're on AWS, actually use the managed self-hosted. It's called in some way, I don't remember it quite well, but the bottom line is the Kafka out of the box that Amazon gives has worked, and it doesn't require maintenance and overhead. And that is a blessing for somebody who has seen Kafka for quite a few years. But that's delivery. We mentioned delivery, and we also mentioned storage. Events, past tense. Stored, very past tense, sometimes for a long time, which means people will sometimes say, hey, events probably should be immutable. And I will say most certainly events most likely, in most cases, will be immutable. But never say never, because sometimes there might come a reason in which you need to alter events. Because there has been a lawsuit, because the judge told us. And the court is not going to be interested that you've put your events into stone tablets. They expect certain effect to happen from your system, and it is your duty to do it. What happens in reality, in my experience, in rare situations, you will need to edit past events. It's an exceptional situation. It doesn't happen by default. Don't assume that you're going to do it. And there is a lot of depends because it varies by industry, regulations, problem space, and so on and so on. But those situations happen. And if those situations happen and you need to deal with them, it's much easier to do it with a database, even if it's a read-only replica that you switch to write mode only to execute this amount of change. And now let's approach this beast in the room. GDPR. Anybody read some bits and pieces about GDPR regulations? Hands up. Yeah. Okay. For the rest of you who do not want to raise your hands, it's an absolutely fascinating, in inverted quotes, piece of legislation. There are multiple texts around it. There is a lot of legends around it. It is quite vague sometimes, and it describes what makes personally identifiable information, so personal data. In what context, what obligations do you have when you're dealing with that? And obviously, if we are building a system and we are having events that refer to customers, then we are going to end up in a situation in which we would like to put, for example, the customer name onto an event and maybe store it forever. Whether you can do it or cannot do it, there is no single answer, sadly. It depends on the context. If you have a lawyer in your organization, get through what you try to do with the lawyer, because they are going to be the one engaged in case there is a lawsuit. So that is a thing. By definition, or by default, there is a very useful workaround, or not a workaround, something that you should adopt as and try not to put PII when you don't have to into events. Ideally, use identifiers, use tokens, use something that is not directly tied to that, but the details I cannot talk because it varies. Caveat, storage. Events, store. How long should we store for? Forever. Do we actually need to? I don't know. One thing that I noticed is people, because storage is cheap, just dump things onto S3. And it's a great way to go forward. But if you don't record what you store and why you store it, and it becomes meaningless applications, then big data vendors will love it because that means more unstructured data to deal with. Great. More bytes for Hadoops to chew. But accumulation is easy, and then all maintenance of that. And is it actually useful? Does it bring us any value? Can we actually do anything with that data? Becomes a problem. And because we're still in the land of delivery, that was something that I've seen recently. I think that's a personal favorite of mine. Somebody had two instances within a system communicating, and they were communicating using events. And to increase reliability, what they did is instead of opening one communication channel, they opened 3. And then instead of communicating through one, they picked any, and then some other events arrived through the other one, and if one of them got blocked, the events scheduled for that particular blocked one were blocked. The other ones were getting through, and that led to a proper nightmare. How do you recognize that something like that is happening? If you are going to see a lot of compensation logic for events coming out of order, for events coming from the same system, and trying to work around reality. Because yes, events can arrive out of order, they can be missing and so on. But if the amount of code dealing with that is excessive, you probably might be around that area of problem. The solution, sadly or funny, is don't go there, because you shouldn't. And do we see any questions? Can't find anything about the left pad drama. Left pad. Lima, Echo, Foxtrot, Tango, Papa, Alpha, Delta. The person in the room, I hope you have it. If not, come to me after and I'll spell it out for you again until we reach it. And then we talked about storage, so serialization. Terrible, terrible mistake to do. Don't do it. Don't use default Java serialization to store events that you expect to work with for a long time. If you think it's unthinkable that anybody did it, I would love it to be true, but it's not. Who here doesn't know how Java serialization works? Okay, great. Everybody knows then. So that we are all on the same page. Too long didn't read course of Java serialization. If you serialize the left and then try to deserialize when your code looks like on the right, it will break. And that seems expected because API is making some reasonable assumptions in some places. I'm not going, there are dragons in there as well. But if you want to do something like that, and if you're doing a demo system and you don't have any real data and you can lose it, absolutely go ahead. But if you value your data and you have to be able to open records, events that you've maybe stored a year ago, you will need to use some other format. Obviously, there are different choices available. Very often, somebody is going to use JSON, and that's a very good default. It works. Hi, I use JSON. Everybody uses JSON. It's OK. Some people have even met the person. So how do we get it done in Java? Obviously, throw an annotation onto code, and we're done. Or are we? This is actually quite a terrible thing to do. Why? First of all, if you change implementations, well, your classes are now, your events are tied to Jackson. If you want to get out of Jackson and we want to do something else, you will have to do it. Frameworks should be stable in output generated, as in JSON is not a new technology anymore, so we should be good on that front. But if another service uses a different library, do you now have to put 2 sets of annotations? 3? No, this is not going to work nice. Unless you're in a company that only always uses a single JSON library, or maybe their own, then you will have something to work around. Refactoring of field names, or sometimes methods, will have unexpected effects. And you can say, hey, but everybody knows this. Yes, and then still those mistakes happen. or not. And you will discover when the other service will try to talk to something generated by a service that has been refactored. Now, what can you do about it? The answer is pretty obvious if you know it, or if you know it well. Test serialization, test deserialization, test symmetry, and test deserialization of older objects. So if you care about being able to open the older object, try to open it and try to see if you can read it. This means you will have to invest time in serialization. It's not a free lunch, because it's not. If you want to know more about versioning in event-based systems, I know Greg Young is supposed to be in this conference. I haven't seen him yet, but if he is, maybe you can buy his ebook. Maybe he might sign something if you print it out. I don't know. I will make no promises for Greg, but he's definitely an expert in the area, and that's an awesome book. And now, I spoke about JSON, so I should also talk about this. Schema, or lack of schema. Because what do we have what do we hear from people that have built an event-based system and a built one? I wish I had a schema, and I wish we documented those events, because nobody really knows what's where. So what do? You introduce a schema. If there is a lot of if-else when it comes to reading events within a system, so you had to spend a lot of time actually figuring out what's in an event, you will probably benefit from having a schema, because that's going to simplify your life, and it's going to simplify the lives of any other developer in the organization trying to solve the same problem. The content of an event is unknown. Trial and error accumulates. You can never be certain whether you can drop something else because you don't have a single source of truth. And that leads to pain, problems, dragons, high taxes, and so on and so on. Schema solutions that you have available. A weak solution is code. Well, why weak? Because if you only code in one language on a single platform, then yeah, code can do it and code can convey that information very well. But now imagine you're running a Java shop, you introduce couple of Python developers, and now they have to look at Java. After the initial, the curly braces, or the other way around, why guys do you use tabs instead of spaces or whatever? It's not natural, which means it's tied to a language, not great. And then you have mobile or web or some other technologies. Maybe you have a VR headset on top of that, and they have to integrate with your events as well, and you want it to be efficient, fast, shiny, because shiny is important, maybe also on a blockchain. And then tying to a specific language will be very limited and tied to the platform that you're coding on. Some platforms cannot run certain languages, and that's hard. So, not code. What is better? Well, something external to the code programming language. One solution is protobuf, another is JSON schema, because for protobuf you have to define the schema, and you can store it, and you can store the schema in GitHub, and then you generate classes that do the communication, and everybody's happy. And also, if you need to do something more advanced that protobuf suggests or allows, you can do a custom, you can do extensions. You can also use Avro, you can use any of the other existing schema solutions. And if you are doing schemas, and you have hopefully a growing business, because we all work in leading growing businesses, of course, event names will end up overlapping. It's a matter of time, it's a matter of number of events, as in how many customer created can you have. Probably many, because there will be different systems, and meaning of those and contents of those will be different, because it depends on who looks at what. Or order created, or bill created. If you have an Amazon bill and you have a GCP bill, those are probably different bills, and it's going to have to be treated differently. Include the domain so that you have some separation, so that you don't have to detect by existence of fields or some other pure black magic whether event names will overlap. And the faster you do it, the less refactoring or unfactoring you will have to do later. And here could be a question, but it's not there, so I've written it for you anyway. Would JSON be too verbose? No, I use JSON for events. I used JSON for events, and it actually works quite well. That's all I can say. If you have problems with that, if you expect excessive storage costs, and it's actually a thing of a concern for you, absolutely go elsewhere, which means do protobuf or do something else binary if you need it. Don't do flat files. That's something that somebody did as well, and no. Now, mistake 5, wait. What is the symptom of an overweight event? Well, first of all, lack of social acceptance, but apart from that, broker, so the distribution layer of the system becomes slower because it has to push more bytes through its pipes. Disk space is going to disappear because you are now storing hogs of events rather than small events. And then too much data is being serialized, which means increased CPU usage and stored and transmitted and deserialized, which means more CPU usage, doing nothing useful. How do you discover that you have a problem? Well, one option is to set a default limit of the size of the event to something like whatever is reasonable for you. Maybe 100 kilobytes, maybe half a megabyte, maybe a megabyte, as in those are all very large spaces. You should probably never exceed them. Probably never. I don't know. It depends. Your mileage will vary. But set it, and then when you have an exceptional situation, you will want to be notified and handle it accordingly. Maybe if you want to do it really, really precisely, you can actually have different sizes for different classes of events and actually work with that. And now, what? We have 10 more minutes, so let's approach one tiger. Exactly once delivery does not exist in distributed systems. And if somebody thinks otherwise, we can talk about it at the party tomorrow. Solution for events, or practical way out of the conundrum of how many times will you receive an event is, first of all, can you tolerate missing events? If you can tolerate missing events, good, one problem is solved. You probably have two choices. You probably have a choice of at least once and at most once. Which one do you prefer? Most people that deal with business situations want at least once because they want to be notified about something important happening, even if it rematerializes. You don't want to not know about taxes being owed because you will have problems. Or you want to be notified that there is a package. If you're ordering something in a wild promotion, you want this order to go through, and probably not too many times. Which brings us to an important word called idempotence, which means effect of applying the same event into the same thing should probably be the same. And good things to check are inbox and outbox patterns. I am not going to explain them here because there has been a lot of internet with and without cats used for this. But I will show you one thing because I tried to type outbox pattern into amazing search. And yeah. Is Google being smarter or is it trolling? I don't know. I'm not AI. But outbox. Inbox pattern looks the same, but in reverse. What is the point of having an outbox pattern? So you have an action, a unit of business application logic that is being executed that is going to generate some events. And within a single transaction, you store the changes to the domain objects and you store the events that would be generated. Why do you do it in a single transaction? Because you want this to be atomic. You don't want to miss the events if you store the domain changes or vice versa. And why not push those events immediately into Kafka or a queue? So that you don't have a dependency on an external system. In case that system is down, your business logic is not held back, and it can still process and eventually reach consistency. And then there is an event delivery agent mechanism worker, whatever you want to call this, that is going to read the events table of the domain application and read those events and then publish them into the event broker, and then event broker is going to do the distribution. Sounds easy. Most of you who are doing events probably know about this pattern. Some of you have seen some problems. Well, I've seen some very fun problems with it. One thing, or the very first thing to watch for, is this. Event table can keep growing and growing and growing and growing. And if you don't have any monitoring there, then you're going to start observing, oh, the system is leisurely doing nothing. We are getting new transactions from the store. Rest of the system looks peaceful. All is great. And then maybe a database is going to complain, hey, I'm running out of disk, or something else, because the event table, the in-flight one, the ones that were supposed to be delivered, are going to grow. So this is a very good place to put some monitoring on, because this is a place in which dragons can happen. And I see that we have, 5 more minutes, so let's start jumping through slides further. There was going to be a question about event sourcing. What is event sourcing, I'm not going to talk about it too much, but I wanted to jump to this slide though. Events and tracing. Why events and tracing? Do you recognize this picture? Some people call it the Death Star. Maybe there are other names in the audience that you want to say. Go ahead. As far as I understand, this is from an organization, dependencies between services. And it's awesome. Those were microservices. I am not going to say whether this is good or bad thing to have. I'm going to say the picture was colorful. More than 0 colors. It's great. With events, you have things that are asynchronous. So you have dependencies between services that are a bit hard to track. And there is one danger there. And the danger is that circular flows, which you have to manage and you have a hard way of detecting, become very easy because you're very decoupled and it's all asynchronous, so this can happen. And you will have to worry about this and how to do it. I do not have a great answer, apart from being proactive about it. And I think, unfortunately, we are going to run out of time, which means we should get to a TLDR version in which I recommend books, and then we look at questions, and then we all say goodbye and thank you. But first, TLDR, if you want to do events, and you want to do events well, and you've never done it, one recommended path of learning or starting is domain-driven design. You might disagree. I'm just sharing what works for me. How? I would say read some of those books. Which ones? Ideally, all of them. You can read them in any way you like, but they are good books. If you need to start one, I will do a very awkward thing. I will recommend a book that says Python on the cover in a Java conference. Yes, but it's actually a good book, and I haven't seen a similar one for Java, so I can recommend it. It's also quite short, reads very well. So yeah, go and read it. It will give you some guidance on how to get things started in a reasonable form. And with that, if you want slides, drop me an email. You have to write me an email. I cannot know that you want my slides and write you an email preemptively because, sorry, I'm not that smart. Yeah. So, questions. In your opinion, what are the best solutions out there for schema registry? That's a good question. I've not seen anything very successfully deployed. I've seen people try to extend OpenAPI recently to use the webhook description to drive this. But I hope, and it's my personal hope, that something like Backstage will get events and event-based APIs as first-class citizen. Maybe that's already in flight. I don't know. I haven't seen it, but I think it's missing. And I think with the amount of events that people are dealing with, that would help a lot. And can you give some recommendations of when to use thin events and when to use fat events? This is a question that's very hard to answer shortly. So I'm going to say it depends, and let's talk after the talk when I'm not being blinded. Thank you very much. May the force be with you.